Hi, in this video we're going to look at the topic of compound measures, and in particular this video is looking at speed. This is both a higher and foundation topic and could be on both calculator and non-calculator papers. For further information you can follow me at Mr_G_Walton on Twitter or at Tupton Maths for further information. During exam season you should also check out #AskWalto. In this video what we're going to do is be able to calculate either speed or distance or time if we're given two of the other things. So for example we might be given speed and distance and we have to work out time, or we might be given time and distance and have to work out speed, or we might be given speed and time and have to work out the distance travelled. And this can either be from something that's written down or it could be from a graph. We're also going to look at being able to interpret the gradient of a travel graph, and remember that gradient is the steepness of the line. And we're also going to work out average speeds if we've been given some information in the question. Let's look at the first example then. In the first example it says this graph represents Sarah's journey home. The key to this sort of question is being able to just analyse what the scales are telling us. So this is distance from home in kilometres. This is time in minutes. Now the question is asking us to calculate Sarah's speed, and it says give your answer in kilometres per hour. So straight away we've noticed that there's a word per, and this is all part of our compound measure. A compound measure just means it's one thing per another thing, and we often can think of things like miles per hour, or in this case kilometers per hour, and there's all kinds of other measures as well. When we deal with density we look at a compound measure there, but this we won't really concentrate on in speed. So let's have a look, see what's happening there. Calculating Sarah's speed. To be able to do that, what we really need to be able to do is to know our speed, distance, time formula. And you may have seen this already in science. You will see that in science you will see a triangle: speed, distance, time, and it's just a quick way of being able to remember how to calculate speed, distance and time. Actually what it means is that speed here is distance divided by time. Time is distance divided by speed, and distance is speed multiplied by time. For those of you that are better at algebra, you might just want to remember it as speed is distance over time, and just rearrange according to what it is that you're trying to find out. Okay, in this example then, let's see what information we've got. We know that her distance from home, as it shows on here, is 18 kilometers. So distance is 18 kilometers. Okay, let's see if it tells us how long it took her to travel the 18 kilometers that she was away from home all the way back down here to 0 to back at home. It says here it took her 12 minutes. So time is 12 minutes. Now the problem with this is that we could just put these numbers straight into our formula and work out speed. It's distance divided by time. However, it's asking for kilometers per hour. Well, we haven't got it per hour, we've got it in minutes at the moment. So we're going to have to do some calculations. We're going to have to work out how many minutes there are in an hour and what 12 is of that. So let's do that. Let's just have a little think what's going on then. We've now got that time is 12 minutes, but that's 12 out of 60 minutes. Now 12 out of 60 is the same as 1/5, or if you've done 12 divided by 60 on your calculator, it may well come up with 0.2. So what we're doing, this is 0.2 hours now. So remember that speed is distance divided by time. We've got 18 divided by 0.2, and that's going to give us an answer here of 90, and that is 90 kilometers an hour. Okay, so we've got 90 kilometres. And again, you can see here the line. Notice this on the answer. km/h, kilometres over hours. And again, if you can't remember your speed, distance, time triangle, the fact that in the question it gives you the unit as km/h, just think about what this means. Kilometres, distance, hours, time, speed is kilometres divided by time. Okay, another quick tip for you there. Let's look at this second example. In the second example, again, we've got a graph. It says this graph represents the first part of Ian's journey. Again, we've got distance from home in kilometres and time here in minutes. However, last time we had a nice straight line coming down like this. This is a curved line. What's happening here? Well, it says, what does the shape of the curve from A to B tell you about Ian's speed? Well, it's certainly curved. So the curvedness of the line tells us something. Okay, let's see if we can kind of just trace over it and just see what's happening. It's getting steeper and steeper as we go. And as it gets steeper, okay, so as the gradient increases, let's see what that's telling us then. Well, as the gradient increases, it actually means that the speed is increasing. This isn't a straight line, so that must mean that it's not a constant speed. It must be that it's increasing, and in this case, that is accelerating. Okay, so what does the shape of the curve from A to B tell you about Ian's speed? That Ian's speed is not constant, because it's not a straight line, and also that it's increasing. Just whilst we're talking about shapes of graphs like this, you quite often see graphs with different parts drawn on. You might see something that looks like this part, which was increasing. You might see a flat part. You might then see another straight line coming down here. And you might be asked to interpret what each of these things mean. The shape coming up like this was the increase in speed. This flat part, and just make sure we're always talking about the same thing, we're talking about distance and time here. This is a distance time graph. The flat part here, well, distance hasn't changed, but time continues all the time. So time keeps going and going and going. The distance hasn't changed, so he's stopped for whatever reason. And this way, distance from home, again, quite steep. So he's travelling faster, maybe you could say, than he was before. Okay, so if we've got a nice shallow line coming like this, it's slower than if we've got a steeper line. This one coming back this way means he's coming back home, so if it's distance from home, he's coming back home. Straight line, you'll be able to work out the speed, if you were out to, by looking at the values here and here. That's the time taken, compared to the distance up here and the distance back here. Okay, so little things to look out for on these speed, distance, time graphs. In this final example, it says Anna drove 35 miles from Southampton to Basingstoke. She drove at an average speed of 20 miles per hour for the first 5 miles, and then 60 miles an hour for the remaining 30 miles. Calculate her average speed for the whole journey. Now, it's not as easy as just adding these two things together. We need to really be careful about what's going on here. Let's think, she's gone 35 miles, so distance travelled is 35 miles. It'd be really useful if we knew what time it took to travel the full 35 miles, because then we could do, let's just write it over here, speed is distance over time. Okay, if we were able to do this, we've got distance. If we knew the time, we will be able to work out the speed. Right, well, let's see. We've got enough information in this question, I'm sure, to work out what the time it took for the first part of the journey and the time it took for the second. 20 miles an hour, and she's travelled 5 miles. So let's see what's happened there then. Well, that's speed is distance over time. So the distance on the first part is 5, and the speed was 20, distance divided by speed. 5 over 20 is the same as a quarter. Now, a quarter of what? Well, in this case, it's miles, and miles per hour. So we're in hours. This is a quarter of an hour. Or you might prefer 15 mins. We'll see what happens later when we do the next part. For the second part, we've got that they did a speed of 60 and they travelled 30 miles. So here we've got 30 over 60, which is half. So half an hour, or if you prefer, 30 minutes. Okay, so the total journey took these two things added together. Total journey took 45 minutes, or if you prefer, 3/4 of an hour. Now we're trying to work out her average speed for the whole journey. Average speed in this case again is going to be miles per hour. This is what we're aiming for. So it would be best if we keep our time in terms of hours. So let's see what we've done. Distance was 35. The time it took was 3/4 of an hour. Now, if you've got a scientific calculator where you can type in 3/4, that's fine. Or you might prefer to turn it to a decimal, in this case 0.75. And on your calculator you can do 35 divided by 0.75 and get an answer, which works out to be 46.67 miles per hour. So our average speed for the whole journey is 46.67 miles per hour. That's not a number that you can guess at by looking at this information here. So you're going to have to have worked it out, and working it out in a very methodical way, breaking it down. Lots of marks for this sort of question, typically a four-mark question, lots of things to do, and if you set it out in a nice neat way, you'll be able to get those full marks. Finally, here's one for you to have a go at by yourself. This talks about Jean, Paula and Rashid are using a treadmill at the gym. Each of them ran for the same length of time, but at a different speed. Work out the values of P and R. So we know that Jean went 12 kilometers an hour over a distance of 5 kilometers. This is going to be the key for you to work something out. Okay, pause the video, have a go, see if you can work out what these constants are here for P and R. Okay, as I said before, this part here is key. This tells us we've got a speed and a distance. I'm hoping the first thing you did was speed is distance over time. Now we've got a speed, 12. We've got a distance, 5. Okay, these are both in kilometres and kilometres an hour. So the time it took is 5 over 12. Okay, so the time it took is 5 divided by 12. Now, if you type that in on a calculator, you get a really funny answer, and it's not a particularly nice one, and it's not going to make a huge amount of sense to you in terms of time that you would know what that means. So let's think about it in a slightly different way. Let's think about how many 12s there are in 60. Now, the reason we're going to do that is that there are 60 minutes in an hour. So 12s, 60 divided by 12 gives me 5. And again, 5 times 5 from here is 25. So 5/12ths of an hour is the same as 25 minutes. Okay, this is important. It means that we now know how long each of these we're running for. I've written 12 down here, it should be 25. So we've got 25 minutes and 25 minutes. Okay, we should now be able to work out the rest. So we've now got distance travelled and we're trying to work out speed. Speed is distance over time. So for Paula, we've got 4.5, and that's going to be divided by speed is distance over time. So 4.5 divided by our time. Now, at this point, you can use your 25 minutes out of the 60, so 25 out of 60. Or if you prefer, you can do your 5/12 still. So divided by 5/12, and that's going to give you an answer on your calculator. And I'll do that in a second. And we'll also do Rashid's as well. Now Rashid, we're trying to work out his distance, and that's speed times time. So in this case I've got 13.8 and I'm multiplying it by, again, my 25 minutes, which is, in terms of hours, 5/12 of an hour. And again, I'll type this in my calculator and see what answers I get. So the value that we get for P, this is Paula over here, P is 10.8. Made a mess there. Just do that again. 10.8. And finally, the value here for R is 5.75. Okay, so what that says is that Rashid has run 5.75 kilometers and Paula had a speed of 10.8 kilometers per hour. Okay, hopefully you got these values right. If you do get stuck, it will be because of the time element of it. I've turned it into 25 minutes here, so it kind of makes sense to me, but actually leaving it at 5/12 is perfectly fine for doing the calculations. It's just that it doesn't necessarily mean anything to you. They're just numbers. So I always try to put them into context as well. Okay, if you've been taking revision card notes throughout these videos, then the thing to do with your speed is the key part of this. Speed is distance over time. And finally, the second part that's key, make sure you convert time really carefully between your minutes and hours. 30 minutes is not 0.3 hours, it's 0.5, and the quick way to do it is if you've got, let's say, 15 minutes and we wanted to turn it into hours, you do 15 out of 60. In this case, that gives us a quarter of an hour. If it's something else that you're not sure about, you could do 12 divided by 60 if it's 12 minutes, and this will give us a fifth of an hour. Well, a fifth of an hour is not something that we would normally talk about, but nevertheless, it's what we've got. So 1/5 of an hour. Okay, and you can do it all kinds of different ways like this. Okay, so hopefully this has been useful. What I would suggest that you do is, if you're not sure about these, have a good look and practice these sorts of questions in your revision packs. Speed is a topic that comes up regularly on your GCSEs, so good luck. Hopefully you found this useful, and if you need anything else, then you can contact me on Twitter. Thanks, bye.